Good afternoon. Thank you. My name is Noah Donaldson. I'm from Annapolis Microsystems. Annapolis designs and produces high-performance processing modules, so often in the OpenVPX form factor. I talk a lot about technology a lot of the time. But I decided, for today's talk, it might be a little more interesting. I figured there'd be a lot of technology talks. Maybe I'd talk about something a little bit different, but it relates to what the technology, a direction I see technology going. So going to speak a bit to this, what we call a COTS2 movement. So it's like a doubling down on COTS that we feel the government's done, and what type of business approaches might successfully address that. So as many people are aware, I'll go through a little histories. A lot of people probably know there was the Peary Memo back in 1994 where Secretary of Defense Peary encouraged government to go with COTS model, so leverage communications, leverage commercial technologies for government use. Since then, a few things happened. VME migrated towards VPX to OpenVPX. And with OpenVPX came great performance increase and swap increase for products that support government customers. But there was a lot of customization was allowed as well, and customization can be good, can lead to a lot of innovation, but some customization isn't always the best. There are things like user I/O pins and things like that made it so that many backplanes, many architectures were very customized and modules were now custom. So an example is our company from 2017 to 2019, we had to produce 6 different versions of one product. 3U processing card. We had to produce 6 different versions just because the backplane profile was different. Really, these products were all the same product. They just had slight different pinout differences. So what happened then is there was another memo in 2013 that Roger mentioned. And from that came Sosa, which you guys have heard a lot about. Is what I would call, doubling down on COTS and attempting to open system architectures further. And from Sosa, I think a few interesting things are happening. It's standardizing the modules. So it's creating types of modules as standards, whether they be power supplies, switches, processing cards. It's standardizing their pinouts, very importantly, so that you can now if you have a module in a particular system and then 5 years later you want to upgrade that module, you can actually have a good chance of unplugging that module and plugging a new module in. Previously that's been pretty difficult unless you get that module from the same vendor and have them customize it with the same pinout, etc. There have also been some other work, like done in the FACE group, to standardize not only the hardware, but to start standardizing the application. So the data structure, the data model, those kind of aspects, so that you could actually develop an application that you have some hope of porting also. So it's leading to this concept of the apps model, where the government, with plenty of hardware limitations, of course, but the government might have some hope of having different applications that they could run on a single platform. So, this will allow to the frequent upgrades of modules for tech refresh. And where I think it starts to really get interesting is where you talk about the business model for organizations and corporations that develop these types of hardware and software. So hardware products that are flexible enough to run independent of applications, so that you could run any application on that product, as well as the converse, so that applications that are independent of hardware, so you could run, you could take one application, you could run it on multiple hardware products. But that takes unlocking the application from the hardware and providing a way to port easily from one to the next. So here's an example. Here's a signal collection application. It can run on a 6U processing card. It can run on a 3U processing card. It could run on a range of other cards, different form factors. And this was developed in such a way so that it's open. There's the ability to port it from one hardware to another piece of hardware. So imagine if you have now a third-party application developer who can develop their own application. That can be the best application ever. It can be the Google Maps of the defense world. And they could now run that on hardware that they develop, hardware that a partner develops, hardware that someone else develops. Or the converse, you can have a set of hardware. So there's a signal processing box that's in a pod on an F-16, so it's gone through all of the qualification for running on that F-16 in that type of environment. This box can be an electronic attack box and essentially be a jammer. But this box could also run a different application. It could run a signal collection application from a partner company or from the box's customer. So I think what's going to get really critical now is to see what organizations, what corporations are willing to open up and actually allow their hardware or their software to be used interchangeably with their partner companies or with the government, whoever may decide to do that integration. So that's what I think is going to be really interesting. Is now we're starting to apply standards to open up the hardware and apply standards to open up the application. So now we have to see who will have that open business model to actually take advantage of those things.